In this video, we are going to talk about testing, but it's going to be something special. It's going to be about the test, what everyone can do in office or maybe even at home, and they don't have to, or you don't have to pay a lot of money. And this test still can be very useful for you. Is this what we are going to talk about, Wasim?
Yes, absolutely. Thank you, Robert, for having me in today. So today our goal is basically to help people who might have limited budget to do critical testing for their product or electronic circuit design to make sure they have reliable designs. I do understand because of the limited budget, sometimes you might not have access to the best test chambers, including vibration tables or climatic chambers. So our goal today is basically to show you there are easy tricks that can help you out to do some of these basic testing. This testing is not to replace what an actual test chamber will do, but basically to help you to understand if there is an issue with your design, it will get exposed. Rather than you going to the test lab and then finding out there is an issue already,
And paying a lot of
rather than
money.
this, exactly, you will pay a lot of money and then you have to wait for the schedule until it happens. And sometimes you might be in a different city where the test lab is, so you have to drive or fly to go over there. And during the testing, sometimes you fail. So our goal today is basically to help you find these inexpensive testing methods to pinpoint the design probably failure before you go and find them out. Tests like there are many testing tools available and testing tricks. Today we'll just go over the major ones that basically make the product more reliable. Like I said, the disclaimer here is not we're not saying this has to replace the test chambers, but basically for people who are limited on a budget in a startup or a small size company to go and do things quickly and get an idea if there might be a failure, where that failure is, so that you can focus and make sure you have the right answer for your product development before things go in the wrong
Mhm.
direction.
Actually, it doesn't have to be even like small company or or I wouldn't call it like a low budget because we used to do this in our company because it's not really necessary to go for big test before you actually maybe try something what you can do by yourself. Like I don't know, we will be talking about this, but I don't know, like putting board into freezer or something. Everyone can do this before
Yeah.
going to big lab and paying money and find out your board is failing. So why not try it first with the tools what are cheap or easy to get, and then if something is wrong you can fix it and then you go to the big official lab or something.
Yeah, I agree with you. So you don't have to feel limited that because you're not a small size company, you can do this. Yes, of course you can do it. If you are on the discovery stage or on the alpha stage of your product development, you're still validating your design and validating your engineering. This is the time you can, as you said, put a circuit board in a freezer and subject it to maybe negative 20 degrees Celsius or up to or down to negative 30 degrees Celsius to find out if there is a component in your design that might get stuck. If there is a memory that might be just jamming and not responding to the commands, or a battery that is not able to charge.
Oscillator.
So exactly, so or the actuator that's getting stuck. So this is the time working quickly, like at your own, lab. You can have that sort of freezer and throw things inside, and it's really pretty quick and pretty easy. And within hours, you will find out if there is an issue. It was very helpful for me. I was testing some batteries, and those batteries, they were basically designed to be operating down to negative 35 degrees Celsius. The question to me, like, I don't want to go and spend the time and spend the money. I can quickly just drop them in the freezer and find out. And I was able to find out, yes, they are working. However, there is a capacity issue. They cannot give you the 100%, probably they can give you 60 to 70%, which was to me a good test.
Hmm.
And it's a good confirmation and validation that this is really working fine.
Hmm. I,
Rather than me communicating with the test lab and saying, yeah, can you book me in? It's going to be within 2 weeks and I have allocated time and I have to go and drive. And Well, this is at my own lab, and I was doing it successfully. Yeah.
Mhm. I think before we go further, we should explain why this is important because I think
Yep.
many people who are even like starting with hardware design or they never starting with professional hardware design, they
Yep.
never really went through this. So it's testing is actually very very important, and I can say we have found issues during testing which we really don't want our customers to find and then send boards for a repair or ask for I don't know money return or something. So why we would like to test?
That is a very good question. This is really well said, Robert. Um, Sometimes designers get so excited, especially in the first prototype. Let's say you have really routed an FPGA with some sort of memories, sensors, and you have spent so much time to do the routing, the PCB layout, and get the boards out. And that feeling of success when you have the board and the LEDs are blinking, like, yes, I nailed it, and the product is now working, and I should ship out. So this excitement sometimes is overreacted because you need to understand having an LED blinking or a buzzer that is buzzing on your board, on your lab, on your desk is one thing which is really important to prove the concept. So in that proof of concept, your goal is to validate, is it working? But before we jump and you go and ship out, you need to know customers are uh, really interested in making sure that this product works all of the time. And if you send a product that might have failed of 20 or 30%, the cost of doing this to your customers is really astronomical. So you will lose money. And most important, you might lose basically
Customers.
your reputation. So your customer might be really upset, and your customer might share this unpleasant experience with others. And this is the least you want to do and the last you want to hear of. You want to identify your issues right from the start of the product development. You want to earn the customer basically trust, and you want to avoid any delays and the time to market. Anytime the product fails while it's in the hands of your customers, to do the recall, it might be 10 to 100 times cost to be detected and early rather than going in the field and having unhappy customers. There might be legal liability in some weird, like some cases. So the goal is basically for us to find these issues quickly, to limit the number of interruptions, and to make the customer happy and not to delay anything. By having that proper testing and understanding why we're doing it, you really will love it because you'll identify issues right away. You will improve your product reliability and you will reduce overall development costs. By finding these issues right on your desk, on your table, it's really super helpful. I'm not talking about the edge cases. There might be some edge cases and edge scenarios you might not be able to resolve right away, but at least the quick ones. If a relay is going to get stuck in the freezer test, and you know you have a bad component or maybe a design that needs to be improved. If a product or a design needs to work in an environment that is really so humid, then you need to make sure what do you need to know? Do you need to add conformal coating, for example? Or if there's an environment that is with sour gas or with high corrosion or exposure to cost. There might be other situations where your product might be subject to high temperature. So I worked with designs. I worked in places where the operating temperatures, like and during the day, could be 45 to 55 degrees Celsius in the shade. In the direct sunlight, it might be plus 65. So you want to make sure when you ship that product with a battery or without a battery that it's really working as expected. There might be locations with dust. So the goal is you go and find all of these issues right away rather than waiting and finding that it's too late. Now I have already designed and have finished everything. I have built hundreds of units. So we want to limit that one and we want to identify issues right away.
Mm-hmm.
Things like I mentioned, like temperature, vibration, water, even RF interference could be causing issues to your design.
Mm-hmm.
So, for example, let's start with the heating.
Before we go to meeting,
Sorry.
I would like to stress out this really can be issue. Like when board is working on your table, it really doesn't mean it's working perfectly. So I would like to stress out this. for everyone who is watching that don't be like, oh, I don't need to test. Everyone needs to test. Okay, we can move on.
Absolutely. Testing is really critical. That's why there are products. So you will compare product A with product B, although they are doing the same functionality. However, product A might be costing more. And you would be asking, like, why would I have to pay that extra money? Sometimes, especially with the product development, with good electronics design, the cost of this is embedded in the testing. So there are people who have been testing so much to make sure you have a very reliable product and a very pleasant experience using that product. Whereas like product B could be working okay, and there is nothing wrong with that. But as a lifetime, it might be only good for a year or 2 years rather than being 5 to 10 years. So I'm like totally on that. And I believe test right away, test often, make sure you are shipping a good product design.
Yeah. Okay, so
Let's
let's
start with the
yeah.
the the interesting stuff, the dry heat testing. There are IEC standards that are available. There are military standards that are available, and there are climatic chambers. Their goal is basically to test for the rate of change or the temperature change for your product. So there are standards that would tell you you can test your product from negative 25 degrees Celsius all the way to 70 degrees Celsius. There are the standards from negative 40, maybe to 85. There are standards for the automotive and for the aerospace. You can go beyond that, maybe 105, 125 degrees Celsius. The goal is once you expose the electronic components and your design to this high temperature, you want to make sure things are not melting, things are still functioning. Your real-time clock, for example, or RTC on your design is still operating as expected. You want to make sure the whole thing as a system is functioning as expected. The quickest thing is if you have an oven. So an oven could go all the way from maybe 60, 70 degrees Celsius, maybe up to 250 degrees Celsius. So what you can do, just open your oven and put a tray. On that tray, you can put probably some protective or non-conductive sheet on that tray and put your electronics inside. Be careful to make sure your components rating are not exceeded with your test. There are components that are only rated for 50 degrees Celsius. Some are only to 70, some 85, some to 125 degrees Celsius. Especially if you have a battery, if you're building an IoT device or sensor, there might be a battery involved. Make sure to be 100% that your battery is rated for that applications. There are batteries that are only good for a certain degree, and going to the extreme might cause an explosion. So please be careful. Ensure your oven temperature is really rated for what you're trying to test.
Mhm. I would like
Easily,
sorry for
sorry, go ahead.
interrupting, but
Yeah, yeah, go
I
ahead.
would like to point out one thing. We are talking about ambient temperature, so be very careful because, for example, if you have processor on your board and you have heatsink, then you can heat up your ambient temperature to 85 Celsius, but the processor itself can be 110 or even more. So this is the biggest problem. Problem is not 85. Most components, if they are kind of passive, they still, if you buy the industrial version, they still will work. But there are components which are going to heat up and the temperature is going to be higher than 85 degrees, and this is going to be a big problem.
No, I agree with you. To your point, Robert, is for that reason we do proper calculation of the thermal of your design. So if you want to design a heat sink, so you need to know what is your ambient temperature. Is it going to be 30? Is it going to be 40, 50, or even 70 degrees Celsius? Because that will impact your heat sink design. That will impact how your processor can see it. Think about the LDOs and the buck and boost converters. All of this is critical to understand what's your operating temperature. Having this working in your lab at 25 degrees is totally different than having this working at 70, because now your ambient will add on top of what the maximum junction temperature of your component. So there is an absolute junction temperature available on your datasheet. Make sure you're doing the right calculation to understand what would be the impact on the junction. If my operating temperature is, as you said, might be 20, but it could be the junction that's sitting at 40 or 50. So there is an absolute junction temperature. You make sure you don't want to exceed it. So for that reason, you could put an NTC or some thermal or temperature sensors on your board on close to those sensitive components to make sure what is the operating temperature or the junction temperature of my board, of my component when I'm exposing the ambient to 70, because that will verify if your math or the calculations you did for your thermal analysis for your components are really matching with the actual one. You want to make sure you're not exceeding, you're making sure you're not really overkilling your design. And start with ramping up slowly. Don't go to 70. You could probably go 40 degrees Celsius. Make sure everything is good. Then you can go to 50. And always make sure you don't ramp temperature quickly. The rate of change is critical. For example, in IEC standards, they tell you the maximum probably is 6 degrees maybe per hour. So you don't want to go start from 25 all the way to 50 within 5 minutes. That way, you might be causing a thermal shock. A thermal shock is intended not for most of the industrial, but might be subject for the aerospace or some military applications. So take it easy, take it slowly until your product stabilizes, then you can go. There are some, as I said, there are some components or sensors. If they see a sudden rate of change, they might just give you false positive reading. So you want to make sure you're going gradually. You use a thermometer, you use a temperature sensor like an NTC, and measure everything on your board and go gradually. This way, it will expose the weakness in any design or any issue in your engineering that was not done right. This is the time to find it. If a heat sink was not properly designed and fitted for your application, this is time to find it rather than you go and ship this out for an application that is outdoor and then you have to deal with after the
Yeah,
fact. Finding this issue right away is really easy.
yeah. So for from my side, from my experience on this heat testing, the biggest issue is usually the, for example, processor temperature.
Yeah.
At high ambient temperature, processor is going to throttle down, and it may stop working, and that's the biggest problem what I've seen.
That is good. So now, Robert, in this case, what would the designer do if this is a processor that is really cranking up and is overheating? What would be the easiest solution in this case?
Change the specification to lower temperature.
Okay, or maybe you can use a fan, or maybe you can introduce something in your design.
It depends
Because
if you
some
can. If you can,
Yeah,
yeah.
if you can,
Sometimes,
if you can change. If you don't, then you have to go back to the customer and say, "Hey, this is my limitation. I cannot make this working." Or in some like there are designers who are working on designing heat sinks and cooling systems inside, so they have the flexibility to add it. Now they can add these features. But for most of like an IoT sensor that is using a battery, what else can you do? You're limited. Maybe the enclosure design might be designed a different way. For example, the selection of the color, the place of the processor, where it should be placed on the product. Should it be sitting at the bottom, at the top, behind another component like a sandwich? So making a mechanical change might improve maybe 2 to 5 degrees Celsius, and that might be it for you to make sure your design is robust. So yeah, I agree. I think the temperature is one of those big ones, especially if your product is going to ship and be used in an outdoor environment that is subject to more than 40, 50 degrees Celsius.
for example, car.
Automotive,
The
absolutely.
simplest
So the
example, I
automotive,
think, car is the simplest example.
exactly. So you're exposing this like all the time. And there are like sometimes not even the car. Like I worked in a place in Saudi Arabia where like the outdoor temperature during the day during the summer, like June, July, you might hit 45, 50, even you just sitting in the shade. And I remember we did a measurement. We were doing some industrial design, and our job, we had like a latching relay that will open 100 amp kind of load. So you could imagine we want to measure the surface temperature. And I was measuring during July, I remember it was 62 degrees Celsius facing the sun because the product has to face the sun. That's okay. So you have to make sure that this is working. So how can you find it? Just make sure that latching relay is really designed for that extreme operating condition. And as you said, I live now in a Canadian city where we go on the extreme end, -40, -35 degrees Celsius. So things might not heat up, but if you're using auto mode or your vehicle during the summer, you might reach to 50, 60 degrees Celsius and maybe even beyond that. So temperature, the high temperature is really one of the critical paths for the design to be reliable.
The next one
Along
is
this
this.
line,
Yeah, this one is very interesting one. So before we start about this, I would like to
yeah, give me
say,
your story. I'm pretty sure you have some nice stories about using the freezer.
yeah, not only about freezer, but I think this is one of the most important tests. At least what I found out, this
Yeah,
is the test where we found the most issues because heating up usually it goes from 20 to I don't know 60 or 70, so there's
yeah,
like 40 degrees difference. But if you go to minus 40 Celsius, that's 60
that's correct.
Celsius difference, and and things are going to work differently. Especially what I've seen problems with memories, problems with oscillators, and these kind of problems. Maybe startup, like starting up the board, booting up the board
Yes.
from at minus 40. These are the kind of things what I've seen, and they really can be problems. And I really like this test because I think if there is something what is working on the edge, like it's working in 20 on your table, and everything looks fine, but it's somewhere in the limiting values. If you go with the temperature much lower, you will find it. And what is the most important, you can repeat this problem every single time and you can fix it. But on your table, it can maybe freeze only once a while, once a week, and you will never be able to find out what the problem is. So I think this is my input for this cold testing. It's super important.
I agree. Well said, Robert. It's the freezer test is a critical. It will expose so many things. And to your point, the electronic circuits like the processors, the RAMs, the initialization of your routines, how the device will boot up, it will be really fun to find it in the freezer. In addition to this, the battery is another critical component. The electrolytes inside your battery might be frozen at that temperature. So if you assume your battery is 3.2 amps hour, sometimes you go into the freezer and you will only get probably 30 to 40% of a regular like lithium ion battery. Batteries cannot charge sub maybe negative 5 degrees Celsius. You're stuck. So if your device is going to work or meant to be working in an extreme cold environment, then be careful. Other things that might be like the enclosure design. So, for example, in the extreme cold weather conditions in the Canadian market, we don't necessarily use, especially if it's industrial, we if we have to use enclosure that is a polycarbonate versus a steel, we will go for steel. The reason is if you're going and doing a service or you need to drill a hole in an industrial enclosure, if it's plastic, then good luck. The moment you touch it in the cold, it might just shatter all the way. Of course, not all enclosures like this, but if it's an average one. Wires. So you'll be surprised if you use like a solid wire that is 24 gauge. If it's really cold, you might just snap it off and it might break easily. That's why using threaded wires might be a better approach for these kind of applications. And like you said, it's easy. Just pull your freezer, put your stuff inside a plastic bag, leave it inside, let it cool down for a number of hours, and do your measurements, and then take it out, let it stabilize the temperature before testing. And this will immediately give you an indication of how things are going.
Hmm.
Now, there are cities in the world or locations in the world, on top of being either so cold or so hot, you will find some cities, like the city I live in, it's called Calgary. During like the springtime or maybe the fall time, during the early days between or the early hours of the day between 6 a.m. to 10 a.m., you might find it surprising the temperature rate of change might be exceeding what's on an IEC standard. For example, I was doing a testing back in March. So the temperature early in the morning around like 6 a.m. during the sunrise was around, let's say, negative 5 to negative 10 degrees Celsius. By the time it goes to maybe 7 a.m., 7:30 a.m., you're like 12 degrees Celsius. So your sensors, your devices might like, what is this? So even it cannot cope with the rate of change. So sometimes even you're tested in the freezer, but there's an extreme case where the rate of change might be difficult. Another city might be like in Texas and Houston, or you can go to Louisiana, North Carolina in the US. So the rate of change might be so much that you have to take care of your design. So you might have to do some tricks in your enclosure to make sure you're limiting the rate of change of the temperature. So definitely, freezer is one of these easy ones, and everyone has a freezer. Everybody has a certain size in your home, in your lab. Please make sure to use it and test the critical components like the displays, the capacitors, the RAMs, the processor.
Yeah, so
And
we
that way you have a,
that's
yeah,
how we used to test also in my very first company. So I remember we had freezer in kitchen, and the assistant, she came to the kitchen and she was like, "Why all the wires are coming out of the freezer?" Because of
yeah,
testing.
it's very funny. It's people are using the freezer. Yeah, I agree.
We couldn't
Sometimes it
close it,
looks
but it can. The wires were
exactly engineers,
thin.
man.
We could close it somehow.
Yeah, I agree. So the ceiling is like if you use the 22, maybe to 24, 26 gauge wires, you can still slide them inside and keep that ceiling. And I agree. I think the freezer is one of the funniest and easiest ones. You don't have to do or turn on anything. It's already working. You just dump things inside and it will work. So really, it's an easy one. And I would highly encourage anyone who's doing designs with electronic circuits, please, it's an easy one. Put it even inside a Ziploc bag and drop it inside, and you'll be surprised the test result that you will find.
Hmm. Sometimes,
Uh,
I'm sorry for interrupting. Go ahead.
no, no, go ahead.
So I wanted to say sometimes I complement this with the freezer spray. So if I know there is a problem, then I can use the freezer spray. So because
Yeah,
putting everything into a freezer, you can't really debug or test or something much. So you use the freezer spray, and you can find out actually which chip is the problem, and then you can just spray it when you are doing the test, and you will very quickly be like, okay, this is the problem.
absolutely. I love this approach. Now, you know there is an issue in the whole design, but now you're suspecting three or four components, like a processor or a RAM. So you can exactly go with the nozzle and just spray that specific area. And if it fails, you know this is where your issue is. It could be there is some I2C or some DDR4 that is jamming up, or there might be a sensor that is not responding and it's just stuck. So using the spray is really super helpful to pinpoint directly where the issue is, rather than there is an issue. Now you can go and focus on where the issue is.
Yeah, and also for test for debugging and when trying to fixing the problem, it's easier to you maybe change your code or you change the register settings. You run it again. You use the freezer spray and see, okay, it didn't fix it.
Oh, interesting. It seems like you have very good
Oh
stories
yeah,
here.
yeah,
I'm pretty
yeah.
sure.
We had problem, especially one with what was it, like Ethernet chip? It was, and we found out actually it was silicon problem.
Hmm,
And it
interesting.
was never fixed on that specific silicon. We had to actually use the compatible chip, and then it was fixed.
Yeah. And don't underestimate these kind of testing. So I was using a smartwatch by some very famous company without naming them. So the issue I face is the following. I do an exercise, a running exercise, and I notice there is the heart rate monitor. So the heart rate monitor, usually it should pick up right away within the first 60 seconds. So when I do running, so let's say I'm running today for 5 kilometers. So I notice the first, excuse me, first 5 minutes of my heart rate is just missing. I'm like, maybe my battery is not charged because I know this is a product that's so expensive and I'm using it and I know how it works. So I repeat the same kind of test again. I'm like now the customer and I go through the same issue again. The heart rate in the first kind of 5 minutes is missing. Then I'm like, okay, there's something strange. Then I looked this up on their forums and I wasn't the only one. Then I reached out to their technical support. I gave them a call. And I said, "Hey guys, this is what's going on. I have my heart rate monitor is not working." They said, "Yeah, this is a known issue." And I was like, "Why this is happening?" They said, "Yeah, our heart rate monitor looking for the vein sizes to be a bit much, and if it's cold outside, cold meaning maybe 5 degrees Celsius, then the sensor might not be good to pick up your heart rate."
Mm-hmm.
Then I said, "Okay, how to solve it? Is there a firmware upgrade that you can guys do?" They said, "No, this is a hardware issue
Mm-hmm.
and you have to live with it. And the only workaround, you have to warm up for 5 minutes, then you can start your exercise." I'm like, really, this is not a pleasant experience. And I was not the only one. And then I'm like, I have that bad image. Every time I think about these smartwatches, about the heart rate monitor, I'm like, have they done enough testing in a real environment for somebody who was just running outside at 5 degrees Celsius? The answer to that may be because the designers were looking or sitting in California and they're happy and the temperature is 25 degrees Celsius, so the testing was working all the time. So always test. Try to test in different environments and try to see how things are working. I'm pretty sure these guys they have the fanciest test chambers, but this is a use case I came across,
They
and I
couldn't
am
put
unhappy.
his hand inside of the chamber, so they couldn't
There,
test it.
there are certain ways, and then there are recommendations. You can flip the smartwatch behind your wrist, and I'm like, really? So it's an unpleasant experience, and I'm not picking on this certain company. It's just to tell you, having that mindset of testing is really critical. It makes people happy. It makes people really trusting your product and your design, and makes the lifetime of your product longer. Rather than it should be 1, 2 years, now it's 5, even maybe 10 years.
Yeah, but
So,
some companies they don't want this. They would like to sell you next one
oh
after
yeah,
two
sure. I
years.
mean, there are exactly. I think there was a comment recently on LinkedIn on why do we have to even do a design that is meant to be repairable. We shouldn't have repairability easy. And the idea was like we will design a product that is reliable enough that it doesn't need repair. However, the flaw to that thinking is like, yeah, I will give you a software update that can only survive maybe to 3 years or 4 years. So what is the point of building
Yeah,
software that is not repairable and I can only sell it for 2 to 3 years?
yeah, yeah,
So there is a business decision, of course. There's a pushback against some like designers that, yeah, this is it, and you have to design it this way. Although we know there might be a failure, that's okay. Let's take it as is. And of course, this is mainly probably in the consumer business. If you go to the industrial, like where systems need to have an MTBF or mean time between failure more than 10 years, you have a very low failure rate. This is not the mindset. That's why we have IEC standards, mill standards to govern how things are brought into the space. Like I said, it's consumer mainly, but there are good companies, there are okay companies. So
hmm
the lesson is, please do use your freezer, make good testing, and find out the root causes and issues right away and fix them.
Okay, let's go to the next
The
one. Yeah, go.
Yes, the next one is the interesting one, which is the IP, the ingress protection testing. Basically, the goal of this test is to make sure your product is protected against probably dust or solids in general, and also against water. There are different degrees, so you could start from IPX, like X4, X5. You can go all the way to IP67 or 68. So the IP stands for the ingress protection. And there are two digits. The first digit is basically for the solids. The second digits or basically is for the water. For this example, IP67, so 6 means this is dust tight. 7 means full immersion in water for 1 meter, under 1 meter for 30 minutes. And most of the smartphones these days, they are IP67 rating. The way they do it, they basically make sure that the device is sealed with the proper gaskets, and there are membrane filters across, the ports, the USBs, etc., so that you don't allow any dust or water get in. Now, if we look around how people do this, maybe I'll go to the next slide. You go to test chambers, they go subject the water from different directions. This is specifically for the IPX5 or X6 to simulate like there is a rain, or there is probably like a water hose that is pointing at certain kind of pressure from different angles. So this is the way they do it. And now you can go and try to simulate that thing if your device is not IP67. So you can go to your shower, for example, and you can use the shower head to point it out at your device, or you can use a water hose and direct the water at different angles. Of course, this will not replace an actual test chamber. This will just give you a high level. If there is a component or if there is a gasket that is not properly sealed, or if there is a hole in your design that you assume there was a good membrane filter and was never added. IP67, like we said, they take the whole device and they submerge it in water. Now, sometimes you don't have a 1 meter deep tank. So what they do, they have less depth, but they pressurize the tank. So basically, they pressurize the tank in a way, and once the pressure changes, they know there is probably a leak in your design. Now, I don't have probably an access to this, so how can I do it? Basically, just bring a bucket that is probably 1 meter high, put maybe a rope and put your design into the water, making sure the trick I usually use, you could probably put some towel inside your enclosure so that if there was a water leak, you know there was a water leak because you can detect the water inside. There are some desiccants that will change their color if they are exposed to water as well. So this is another way to find it. I have done this tons of times in the past where basically we have a mini enclosure, probably the size of your hand. This is an industrial design that I wanted to verify in our lab before I go to the test chamber. So I have probably 2 or 3 holes. One of them was for the antenna. That was the weakest point. So we had to use a gasket. It comes with an antenna with an RF, like the SMA type. And yet it was because the enclosure was aluminum, kind of aluminum type. So the hole was not uniform. So there was still some leakage. And we had to find out it's coming from that location. The solution to this was to have a proper kind of sealing. So we added another kind of gasket to seal that hole. It was an easy thing to me. It took me probably half a day to find out I had an issue, where the issue is coming from, and then I acted immediately. I went to the design and I fixed the design. I know where my issue. Rather than now I go to the test lab and failing without knowing why it fails, they will just give me a report, your product has failed. Now I know ahead of time and I didn't cause any delay in my product development. So yeah, this is an easy one that you can do. Just fill water and see how things are working.
What about dust?
Dust, that's a good question. So for the dust, now I didn't have pictures to show. I wish that I had. So what I used to do, I have a tank. Or you could say a big container that was all made of transparent or clear kind of material, so I can see the inside. And what I used to do is basically I had a vacuum, then I connect the vacuum, the hose of it as a blower.
Mm-hmm.
And then inside that big container, you have two options. You can put the powder that they use for kids, or you can use real dust. In my case, I use real dust and then blow the air. And then there is a fan as well. So I was like blowing air, and with the vacuum, I was blowing and sucking the basically the whole air. So that way, I was able to go and see in a real environment. Maybe I was getting 30 kilometers an hour with the fan. It was a big industrial fan. So I was able to simulate it and having dust. Of course, this is an extreme case of building a test setup. There might be other setups, so you can put a small enclosure or a small tank that is all clear plastic, and then put your stuff in and put some powder, maybe the white powder, and then that white powder basically you can go and shake your device. So maybe you can use a shaker if you have, or you can vibrate it with a vibrator, or you can just with your hand you can do it so that you can cause this uh, turbulence inside and cause the dust to go into your design. Or you can blow a mini fan inside and you can let the air go and circulate, and that way you can test for your dust. Again, Dust is a kind of interesting thing because there are fine dust particles that are defined in an IEC standard, and there are large dust
This is what I
particles.
was thinking about. Yeah.
Exactly. So you can build that thing easily, where a tank, a fan, or a blower, a vacuum, and then you can put your device inside, and you can collect dust anywhere you like from your environment. And that way you can blow the dust around your product and find if there are issues for your sensors, for your sealing, if there's anything that might get into your ports, like a USB port or an Ethernet port. So if you have the right sealing in place, you can find this out easily.
Is there difference between like the water test and dust test? Like if it's okay for water, is it going to be okay also always for dust?
Okay, so if it's good for water, so I know sometimes because the molecules of the water are really tiny. So if you did the test for water, why would you need to bother about the dust? The question to that is basically there are, uh, let's say your device is meant to be not really water, like operating in a water condition, but it's raining condition. The dust, if it accumulates across some sensors, so there might be a light-based sensor, like let's say a light, like a resistor light detector. So if you have that sensor and then you have water and dust building on top of it, so that way
Mm-hmm.
maybe you want to make sure like your design, the surface itself is coated with some material to avoid that one, because if there is dust buildup, then the sensitivity of your sensor might be affected. So yes, sometimes water is enough to test if things are sealed, but what you want to do as well is you want to make sure, for example, if you have a speaker in your design, so if dust settles in, would your speaker still operate and doesn't have any issue? So both are equally important. In your application, you define if dust is really, if your device is not operating in dust environment, maybe water is okay. But I believe both are equally important, and having just the water itself to prove that dust shouldn't be entering my system, basically it's equally important. The other thing, sometimes it's not dust, sometimes accessing the port. So there are devices where it's not IP60, it's IP54. So it's not the dust fine particles, but you don't want a finger to cross an opening of your device because it's hazardous, because it's high voltage, for example. So you want to make sure, like, yes, water might get, but I don't want people to put their fingers and get shocked, for example. So this is where you go to the IP54, for example.
Mm-hmm.
So yeah, it's dust is important, but sometimes it's other applications require that you don't access or you don't have easy access to block the sensor or for safety reasons.
Mm-hmm.
The next thing is the high humidity, and this is an important thing. And humidity in certain locations, you might get exposed to high humidity, something above 85%, especially if your design is meant to work in locations on the coastal side, close to the sea. So usually the humidity might be even beyond 95% relative humidity. And your goal, especially if you have a design that has a real-time clock or you have sensitive components that might drift with the humidity, you want to make sure that the accuracy or the tolerance or the precision of your measurement is not impacted a lot. Or if you want to do some basically compensation to compensate for the humidity in your firmware, then this is the way. Usually we do this in a test chamber, climatic chamber.
Yeah,
You
because
go, you
yeah,
set it.
the more expensive chambers, you can also set humidity and also temperatures.
Exactly. So, and this becomes, you might get to the 20,000, maybe 50,000 US dollar just to get that sort of test chamber. Now, I don't probably have a budget for that. So, what I can do, you can literally do certain things. So, this is a test that I used to do. And this is my little sauna. So, a sauna is a device that you can use at your home, especially in locations where you have high dryness, where the air is so dry. So basically, this is, think about it like a pressure cooker. So it has water inside, and then it will send through a pipe you can see on the left picture. That pipe will
You
just
can use mouse. You
expose
can show it.
exactly. So
I mean, you can use
yeah,
yeah.
you can see how, like, this is where the water we put it in the tank, And then this basically, this device, you power it up and then it will heat the water. Once the water is heated, it's like a pressure cooker. So the humidity will just escape through here and it goes to the back. And then this is basically the tube that has a container. And then it will, all of the hot air plus humid air will be exposed to your design. And I was able to get, I think, more than 95% relative humidity inside this chamber. It's like really almost fog inside. I found it very useful if you're designing a product that is meant to be used in really next to the sea. If you have an environment that is extreme in humidity, this is an easy hack you can do. Now, let's say you don't have this hack. This is a sauna that I cannot purchase. You can do another trick, which is basically using the steamer. So you can use those that use it for your clothes, and I'm pretty sure you have easy access and you have different variants of this. Just take that one. Of course, you have to be careful how you apply the test to which component. So there are designs that are conformally coded. So there are PCBs where you code them just for the sake of protection against like the dust, the particles, and the high humidity. So how would you find out if your conformal coding is working as expected? So you can go and take the steamer and subject that steamer on top of the probably the high risk elements on your design. If it was a processor, if it was a DD RAM, if it was probably a real-time clock or a sensor. So this is an easy way where you can take that steamer and just subject it to your design. Of course, you have to maintain certain distance. You have to maintain like because it's very hot and
It's
be
hot.
careful
Yeah, I
how
was
you.
exactly thinking about this.
Yeah, yeah, it's very hot. It's maybe beyond 50 degrees Celsius, so be careful when you're doing the test. But I find it very useful, especially if I have a design that has a real-time clock that might drift with the humidity. So this is the way you can just point it out closely and then just let the humidity settle and see if that real-time clock is drifting and how much is that drift. And then you can reinitialize and like you said before, Robert, repeatability. So you can repeat the tests. You don't have to worry about it because this is you're doing this while you're sitting in your lab. So you can repeat it easily. If you don't have access even to this, you can use a kettle. So a water kettle, that's the one shown in here, it will give you not the best kind of high humid amount of air, but basically it will give you enough. If there is a failure, if there is a potential risk for things that are operating at the edge, this will expose them. This will make sure that you'll get the failures right away rather than you have and go and spend so much time to go to the test lab.
But if you use these steamers, are not they going to create the water drops on the board?
Absolutely. There might be condensation. So that is why make sure like when you have your board, please don't have your board coming from a cold or a freezer test. And right away you do this. And make sure you have maintained a distance. So if you have a very close proximity with your board, then I agree with you. It will be condensation and water drops all over the place. So maybe what you can do, you can put one thin layer of probably some cloth so that you limit that flow of humidity and then only get the high humidity getting into your device so that the water drops are not, or the condensation is not caused on your design. So definitely, this is a good point. Mainly when I was doing the test, I had a conformally coated board. So to me, I wasn't worried because I
Mm-hmm.
am coated. But I agree, if your board or your design or your port is not coated, then you want to make sure you don't cause condensation. In some situations, your goal is really to cause the condensation
Yeah.
because you might be working in an environment that you want to cause the condensation and see how does the electronic circuit respond to that. Along this line is the coast or the salt water and corrosion.
I
If
was
you operate in
exactly
the
thinking about this.
exactly. So what was your experience doing this? How would you resolve it,
I
Robert?
haven't had, I don't have any experience with this.
Yeah, it's basically there are like IEC standards, there are military standards as well, where you can test for the corrosion. The goal here is like, as you can see in the picture here, we have a board that probably is exposed to high corrosion that was probably working in an environment that is too extreme with probably not the right sealing. There are critical components in the design. For example, let's say you have um, um, probably a screw, or let's say you have a component that is mechanical, and you want to make sure it's already galvanized. Maybe it's already having a sort of coating or protection. How would you make sure that this will sustain the salty water and be against the corrosion? So the easy trick, what you can do is you can go and put a jar of water and add salt to it. So the idea, you can add certain amount of salt, probably 3.5% salt solution, by mixing 35 grams of salt into 1 liter of water, just to mimic the sea water. So if you made that mixture, then you have two options. So there are components, like if you're testing a mechanical component, like a screw, or a port, a USB port, or something that you want to make sure it's sustaining the salty water. Or if you have a design that is conformally coated against really the water. So probably you want to find out if this is really working. So you can bring in that jar and you just drop your component inside. Now, this is, an easy one, but there is an advanced one where you can make fog. So you can use an ultrasonic fogger and then put your devices here and then heat everything up. And that way you can probably causing that sea salt water effect so that you can show how your device is responding to that corrosion if it has to be. So the reference here for this test equipment that you can go and build in your lab to really, it has a controller, it has an ultrasonic fogger, it has basically a structure to hold the devices, it has a mat here basically to absorb any or catch any drippings. And this is a tank that it is a clear, so you can go and simulate if I have that really a coastal environment that might be exposing corrosion. This is an easy way where you can simulate it. You have to expose this probably maybe 12, 24, or even 48 hours. Um, you could spray, if you want to use a spray, you can spray it with the same method for the freezing. You can spray water with salt as well. So there are different ways you can check for your ceilings and for your components to make sure that are really properly designed for these kind of environments. One of the easy things people use for the printed circuit boards is to do conformal coating. There are different kind of coatings where you can go and coat your components and maybe part of your connectors so that you can avoid this kind of corrosion if your product is meant to be used in these extreme environments. Some of the extreme environments, in addition to really the coast, is basically industry like oil and gas. There are locations where they have high like sour gas. So there might be another spray that you can do to protect or coat your parts against, especially the connectors against this sour gas that might cause like the corrosion. So, like I said, there are different ways you can go and build that test. You can go as easy as this one. I use this personally. I was using a fan, and that fan was coated, and I wanted to make sure the coating is working. I have another version of another component where I wanted to verify, like now I know it's not coated, but if I would cause the corrosion, would my component still work?
Hmm.
So it helped me a lot. I spent, I think it was 7 days. I left it in the salt water. I even added vinegar in it just to cause more corrosion. It was really crazy. At the end of the day, I took that component, I turned it on, it was working. Of course, the lifetime is not, but I want to make sure, like, is this design capable of sustaining this extreme environment? So this is around the water in general, the IP67, the corrosion. Now we will jump into the vibration.
This
This
can
is a
be very
funny,
expensive test, actually.
very, very expensive. Vibration tables, for people who might know, could be really 20 to 50K US dollars. And having a vibration table that works at the frequency of your interest, because usually the vibration is between maybe 5, 10 hertz all the way to 500 hertz. So it's really super expensive to have a calibrated chamber to do the vibration on a table.
And you have to run it for a
I
long time.
And yes, and you can run it for a long time. And this is usually like I worked previously in one of the companies where we had the really the pleasure of having this in our lab. So we have a vibration because it was a military kind of product. And You can go and listen to all of the vibrations. It becomes so noisy, and they run it, as you mentioned, for like days just to make sure that this is really working, simulating the real environment. Now, I'm not talking about that extreme case because you need to go for that vibration table. If you don't have the budget for it, maybe you need to do a test lab. But I'm talking about people like you're building a device, a sensor, a battery-powered application. You want to simulate quick things like people shipping the device. If you ship a device, maybe by air shipment or you're shipping this by a vehicle, what can you do to simulate that thing? Are there easy ways? And the answer to that, yes, there are easy ways. So the first and most important one, as the critical one, as easy one, is go to a vehicle. So you can put your in the trunk, you can put it in the back of your vehicle. Of course, you have to strap it and do it in a nice way. Maybe you need to use foam to hold things. Maybe you need to use tape, mounting hardware. The idea is just put it in the back of your truck and start driving. Drive in terrains like maybe you have bumps, go on bumpers, maybe go very low speed, like 5 to 10 kilometers an hour, because there are vibrations that might expose your screws inside your enclosures to pop off at that certain frequency. Maybe you need to go on a terrain that is off-road. So the goal is to expose your mechanical components, the springs, the screws, everything inside your enclosure to really get exposed.
So heavy
Now,
components, I think they can cause problems.
yes, exactly. So if you have a heavy component, let's say if you have a fan, a latching relay, you have a knob that a user can use, so things can pop off easily.
Heatsink.
Sometimes, yes, a heatsink, exactly, a heatsink. There is a, I think, on EV blog, he did, I think, a test for the heatsink for one of the maybe LM maybe series for the regulator. So if you don't have the right kind of um, torque that was done properly, or maybe the solder joints, your solder joints might just pop off easily because there was a cold solder joint, and maybe with the little vibration, it will just pop off and cause a damage to your product. So it might not work. So there is an easy way that if you want to simulate it, go to a truck. So this is one method. The other method is if you go to this website here, you can go and build this mini table. So there's basically a motor at the bottom of this table, and there are springs, and you can control the force or how much shaking you can have. So this is a shaker that you can build easily. So you can control this and it will just vibrate. So this is driven by, if they want to shake the concrete, when they prepare the concrete, they have a shaker. So it's the same kind of concept. You have a motor at the bottom of the table, and then you control the amplitude of those vibrations using this control circuit. If you don't want to do this, then an easy trick is basically the massage. If you have seen the massager guns that you use it for your back or maybe your lower back, so this thing you can use it. If you have a mini container, you can put your product in. You can basically hit your design so that you can cause these vibrations. They are not exactly the same vibrations that might be in the field, but this will expose any issue that might occur in a weakness in your design. Like you mentioned, it could be a heatsink, it could be a solder joint. Easily, if you vibrate it with this gun, it might be easily detected and you can find the issue right away.
I would like to point
So,
out
yes,
uh, when we are doing this vibration test, we actually need to consider what kind of direction we would like to vibrate, or you need to
yes.
change the board because the influence will be different.
Totally. This is a very good point, Robert. Thank you for reminding me about that. So when you do, like there are certain orientations. So if, for example, you're shipping your product and you're mounting that product in a box vertical, so if you do that tests, it might not expose it. So maybe if you put it horizontal or maybe on its side, it might cause the issue to happen. So I agree with you. The right testing of this, it will be more successful if you do the right orientation while you're doing the testing. So go at the corners of your product, go at the bottom, go at the top, make different orientations so that you can cause the failure to happen. And this is an easy one. It's not really complicated, but seeing the issues right away rather than waiting until it happens in the field. Next one is the I think you love this thing, the ESD. Well,
Yeah, yeah,
every
yeah.
electronics engineer,
So
the ESD is, yeah, go ahead.
I have story for this one. So if someone think like, oh, I don't need to use this test, you do, you do. Once
My
we
friend, you do,
once we designed a product with audio chip, and there
yeah.
was a recommendation to connect the analog and digital ground through a ferrite bead.
Oh my God, please stop this.
And basically, we sent the product for certification. We didn't do this preliminary testing. We sent it for certification, and they were like, "But your product is failing ESD test." How it's
Oh,
failing ESD test? It just stops working. And then we found out that the bead was problem, and we had to replace it by 0 ohm resistor, and then it worked. Basically, always when they apply the pulse or the spark,
yeah,
then it discharged through the chip and it damaged the chip.
yeah, that is well said. Basically, ESD, the electrostatic discharge, is one of those little tiny things that you might think, yeah, why would it fail? No, it might sometimes kill a chip if the amplitude or basically the voltage range was so high. And you can buy an ESD gun that can do a proper ESD test as per the IEC standards. So there are levels like 4 kilovolts, 8 kilovolts, 15 kilovolts,
A number of
both plus
pulses,
number of pulses, how many and how you direct this. And there's the
polarity.
air discharge. Exactly, the air discharge, the contact discharge test. Of course, if you have the budget to go for it, please, I advise to go and do it. And I have used this in the past, and it was really very helpful. And like you mentioned, I had the design maybe 10 years ago. We were working on an ESD, and there was simple like ferrite bead. And I'm like, okay, the moment you have that ferrite bead, it basically fails the whole thing. You remove that ferrite bead and do that short, and it's gone. So definitely, and this is along the line of having gaps in your return path. And I'm pretty sure many people have watched your interesting video with Rick Hartley. It's about the EMI. And I'm like, man, this is, I think, a video every hardware design engineer, electronics engineer should basically watch. It's basically, it goes over the first question, where's energy in a circuit board? Is it voltage or is it current? And definitely it's neither of them. It's basically in the electromagnetic fields. The moment you understand that concept and you start now thinking how you should design the stack up of your board, where you should have your return paths of your signals, and how you can separate the analog from digital, the high speed, and doing a gap in your return path, this is a recipe of failure in many applications. The moment you start having a gap and you have high speed signals crossing that gap, then good luck, my friend. Welcome to the EMI world, and then things might be failing quickly. So yeah, that is a very good video, Robert. Thank you for having Rick.
Thank you.
And please, if you can bring him again. I remember when I posted about this video that you have shared with the community, there was one comment by a guy, like having Rick describing this like horror movie. It's like you don't know what we have been doing for the past number of years in product design, and now you've learned the hard way. It's really interesting. And along Rick Hartley, Daniel Beaker, Ralph Morrison, these gentlemen, they really are helping to shape that kind of understanding of the EMI and how the things are working. So yeah, the ESD is, like I said, ESD gun might not be available, but easy tricks. You could easily grab some coins in a Ziploc and just jiggle them and then try to bring that closer and touch the device's exposed
Is this
metal
going to
parts.
work? I never tried this. I should
Yeah,
try
yeah,
it.
there is an expert. Maybe I should share, like, there is a video by a nice gentleman on the, he's into the ESD. I think he does it, and then there is a scope, and then you can see the pulses right away. So it is working. So this is one of the easy one. The other that makes
I'm
sense.
sorry, I'm going to interrupt. So, do you need to use special metal coins? Do you need to use like
Uh,
copper and I don't know different ones, or
yeah,
I don't
yeah,
know?
something like this. So usually those are the old copper kind ones. So if you basically have them in that like in the plastic bag, So any that those sort of metals will expose that kind of charges, the electrostatic discharge, and being close to a metal part of your design, it will right away travel through the
Okay.
air.
I need to try
So this
this.
is,
I need to try
yeah,
this.
yeah, you go ahead and try it. So especially if you have a controller, it might reset. So go close to the reset line. So if you have a reset line or a JTAG maybe, just go do it next to it. So this is easy trick. There's another one basically. You can use a lighter. So if you have a piezoelectric lighter, just to cause that ESD event, so you can go across if you have a port like a USB port, if you have Ethernet port, so you can go and try to shock the design. This has been published a lot, and there are many people doing it online, and you can see it. Make sure you're doing this experiment really in low humidity environment to maximize the static, because with high humidity, the chances of having high energy will be limited. If you have low humidity, this will maximize the static. Try to avoid really contacting high sensitive components and damaging them. So try to do air discharge first. If the air discharge is working fine, then maybe you can go to the contacts or the ports of your product. So that way, and go with like if you have a smaller, lighter, or like smaller voltage, start with that voltage. Don't go to the extreme. Usually your target is between maybe 4, 8, maximum 15 kilovolts. You don't want to do more than this. And when you hear that this high voltage, it's really like you're talking about nanoseconds. So the rise time and the fall time, it's really nanoseconds. So you don't feel it. However, the electronic parts do feel it. There are IEC standards that might tell you a failure is defined if the system does not recover by itself. There are like standards, they would say a reset is okay as long as the device can recover afterward, but a damage to the design, that means this is a failure, you cannot proceed. And you don't have to go to a lab, you can really simulate this easily by having some really jiggling coins inside a bag or using a lighter.
I would like to,
Mhm.
again, say, well, let's go a little bit to this. There is
Yep,
actually a whole setup usually when you use this ESD gun.
yep,
So maybe even if you try with this lighter, maybe you may would like to have some kind of, I don't know, metal plate or something. And usually this is only applied to the things what people can touch. So
true.
so don't apply it everywhere on the board. Yeah,
No,
place your
no,
board into
absolutely.
enclosure and all the openings where people can touch. That's what needs to be tested.
Exactly. This is a very good point, Robert. Is like it has to be like that metal kind of sheet. Usually they have that test table. It has certain dimensions, and then this is grounded, and then you go with your ESD gun tip. There are two tips, one for the ESD charge for the air gap discharge, and there is one for the contact
So
discharge.
I would like to point out if someone doesn't know. So air discharge,
Yeah.
you see the spark, and the
Yes,
direct is when you touch, and
exactly.
so there is
Exactly.
no
So
spark, but the pulse goes inside.
they go directly. So exactly. So there is one that you just travel through the air and then you get the discharge through the air to your component. And like you mentioned, the goal is not to go and pinpoint everything in your board, otherwise it will be dead, but only the points where the user might have access. So if it's a charging port of your design, or if there is a button that a user might press, so this is the area where you want to focus on and make sure that you're exposing this place only, not anything else. There are, like, as you mentioned, Robert, there's a setup for it. There might be also adding uh, a plate or a sheet of metal, and then you go off that one and you apply the discharger to it, and your product is closer, and there has to be certain distance. So the IEC standard does define
It's on internet.
all
I
of
think
this.
when people search for ESD setup or something, they will find it.
Exactly. So once you go and you can easily find that one. Next one is the RF immunity. And now RF is like, again, there are many nice people. Like Kenneth White is one of them. Probably you know him already, the EMC
From
doctor.
LinkedIn. I know. Yeah, yeah, yeah.
Yes. Yeah, maybe you should have a chat with him one
I
day,
think I talked to
Robert.
him, but it was maybe a long, long time ago, and I think he was
Maybe it's
busy.
time to go back because he's the guy who makes all of these nice kind of experiments to cause failure or detect failures on your board, especially from the EMC point of view. And this is a setup I'm taking this reference by really Kenneth White, unusual EMC sources. So one of the easy things. he does is something called a chattering relay. So, what is the goal of this experiment? What we're trying to do here is to simulate an RF energy source that will throw RF energy in the space and then see how the device responds to it. So maybe the device would reset or maybe it will malfunction. So how can you send RF energy? So there are different techniques and different methods you can use to simulate that. But the easiest one that will generate a broad RF band of, RF energy is using a chattering relay. A relay is a chattering relay. It's a relay that is connected in a way. So you apply the AC to the relay. Maybe I'll go to show you the circuit. So this is how the circuit looks like. So this is your relay. So you apply it to one coil. The other side of the coil is connected to the normally closed contact. And the other input goes to the normal. And then now once this is energized, it will go and open.
So this
And
is like
then
the old type of rings.
exactly. This is exactly the old start of the ring bells. So it will open, it will close, it will just cause this all of this fancy. And this, if you use that old ring, maybe you can find it these days. And then this is the way to connect it. What this will cause, because of the closing and opening, that chattering kind of sound or buzzing sound, it will create an RF energy, a broadband RF energy. Now, we don't have control over if it's from, let's say, 80 megahertz to 1 gigahertz or 2 gigahertz. The goal here is really to see how the product or the electronic circuit board is affected. So there might be an issue where you have a controller that might reset. So maybe the standards will define this as an okay, as you can recover by yourself. So if the controller can recover immediately, then this is a pass. If the device does not recover, it might fail according to the standard. So you need to be probably bringing that relay maybe 10 to 20 centimeters from your board and see if that might cause any issue. And you can detect that RF energy by putting an antenna to your probably spectrum analyzer, and you can see that whole spectrum of energy. Where is it coming? What frequency band is this? Like I said, it's easy. You just basically you're simulating the RF energy flow, and this is the RF immunity test, which means you're trying to see if your system is immune to the RF energy that's coming from the outside world. And like I said, Kenneth White, if you guys know him, make sure to follow him. And hopefully, Robert, one day you can post him because he has so many nice experiments on all of these fancy tools for the EMC. Uh, that is, I think, the end of our slides today. So there are so many things that we might not be able to cover today, especially on the EMC.
EMC.
EMC
This
is
is
a
exactly what I was thinking. Like people are now like, but what about the
RF.
EMC?
EMC is, man, we can spend hours on EMC. So you can do a test tool really for the RF immunity. You can do more testing on the ESD. You can do testing to simulate the surge, like the lighting strikes by the during the rainy days. You can do tests for the earth fault transient, the EFT. You can do also testing to detect how much RF energy, which is the RF emissions by your device to the environment. But that gets a little bit more complex because you need to make sure you're sitting in an environment that is isolated from any RF source. And you need to use antennas. So there are like the topic of EMC is really a great topic. And it comes down to understanding how the energy flows into the electronic circuit board. It flows into the dielectric, into the plastics. If you know how to control that flow, then we have a better kind of design that works right from the first time. Environmental conditions are really the first step for the proper product development and testing, like dry heat, dry cold, the damped heat, the salt spray test, the high humidity IP67. This is the first entry, I would say. If you can go and start your product development alpha testing with that in mind, that will help you really to expedite your testing, to make good product, reliable product design, and make your customers happy. Start testing early, build reliable products, save money. And these dye methods are preliminary testing. They are not meant to replace any test chamber by any means. It's just for you to go quickly through your product development cycle to find answers to your concerns.
Mhm. I
Yeah.
would like to. I would like to continue. So, first, if someone is interested about EMC test, actually I've done a number of videos about EMC testing, and some of them are covering like in-lab testing with not the expensive setup or
Fancy tools, yeah.
something. So have a look on these videos. Uh, People will need to buy something for EMC
Yeah,
testing. It's not as simple as what we were talking about
exactly.
now. Like everyone has fridge or oven, but not like maybe spectrum analyzer or the tent. I don't remember how it's exactly called for the
Unhealed
EMC
chamber.
testing. Uh, and I would like to add about these testings, what we were talking about. Sometimes some of these things can be rented. So it doesn't mean we have to buy the environmental chamber or we have to buy ESD gun or something. It can be rented. And it can be then more available for people. But again, it would be only kind of preliminary testing. Always for official testing, we have to go to like certified lab and doing all these tests, and these are expensive.
I agree with you. Thank you, Robert, for reminding me because you have created so many videos with so many nice people on the EMC topic.
Now you are one of
And
them.
oh no, no, I hope so. I'm pretty sure I'm early in my journey into that, but there are so many nice people that you have already hosted, and I have personally learned a lot. And this is just a word for our community. There are so many nice people that you need to follow, and one of them is you, Robert. I've been following you
Thank you.
since 20, I think 15, I think 10 years ago. Remember when you had your open racks kind of board design that you had it as open
Yeah, yeah,
source?
yeah.
This is really, it was like a gold mine. And I know this is how early I started following you, especially from your very beginning of the Altium courses and how you can start from the schematics. So your content is helping really to grow our community, including myself. There are so many topics that are helping the community to learn. And Robert is one of them. There are so many nice people really that are helping the community. And then you can just follow us on LinkedIn. You can just see Robert is very active and he keeps sharing the nice stuff. And I do try also to help. So follow me on LinkedIn. There are other people too that are really interesting. So just stay in that kind of community. You're really attached to the kind of the latest that is happening in our technology or electronics development. That way you'll learn and ask questions. I might not know everything, so I will ping Robert and I say, "Hey, Robert, what do you think of this test?" He would say, "Yeah, we did this test using this method." Or you might be interested in doing really some low noise amplifier design. And I think, Robert, you hosted Art Kai from Texas Instruments one day, and it was about the analog design. So you can reach to Art Kai on LinkedIn, for example. So this is what has helped me a lot through my journey in the past, I would say 10 years, staying connected with the community and also sharing your thoughts. You might have done an experiment that we haven't seen before, and then we can make it better, and then we can help the community to learn. So thank you, Robert, on behalf of our community. I really love your content, and please keep sharing these nice videos and nice content. And as this is really growing our community and helping us all to be successful, building reliable products and understanding how the electronic circuits work by hosting these nice people. So yeah,
Thank you.
thank you so
No,
much.
thank
Thank
you.
you.
And I have to thank everyone actually who was in my videos and all the future people who will be,
Yeah.
because I don't know everything. And always when I make videos, I always learn something new. For example, today, the lighter, it was good. I never thought about this, like using the lighter for ESD testing. Good one.
Yeah, for sure. We people is learning. So yeah,
Uh,
again, keep this is a learning journey. Yeah.
Thank you so much, Wasim. Would you like to say also something about yourself so maybe people know a little bit what you do?
Oh, yeah, sure. I should have started this earlier. Wasim, I'm basically a guy who started early When I was like probably 13, 14 years old, I was interested in electronics. And at that time, we didn't have YouTube, we didn't have internet. So the only thing I had was access to libraries and magazines.
And old
So,
TVs to
and
disassemble.
yes, so the only thing was how can my curiosity was around how can I build electronic circuits. So I did my degree with the hope to answer these questions. How would people select the resistor value of being 4.7K? Why is it 4.7K? Why do they add this capacitor? How does the capacitor work? That's how I started my journey. And then after I finished my degree, I'm like, it was mainly mathematics, mainly. There are some electronics concept, but I'm like, no, that does not answer my question. Then I started, joining the field, and I started my career as a hardware design engineer. And I have now accumulated, I think, more than 19 years. Basically, I have designed more than 10 products, and with great teams, we were able to design products that have been, I think, running. One of them I'm very proud of in an extreme condition, a smart energy meter. More than 1 million units have been shipped and used with more than 10 years now working.
Wow.
So this is one of my greatest milestones in my career. Then another product that has shipped thousands of them, maybe tens of thousands in the North American market for the oil and gas industry. And then after I progressed, now I'm managing the product development team at my company. And basically, we develop the technology. We start from the idea, from the discovery, all the way we go to the mass production. It's a very interesting journey that I love and I like to share with our community. And my mission is basically to keep building these great stuff and help the community to grow and make sure people have access to the information, to the right information, so that we can all be successful. So yeah,
So
that
so
that's
nice
that's
word.
me in short.
So nice
Yeah,
word.
and keep following me on LinkedIn. I'm very active on LinkedIn. So if you have questions, if you have any idea to think or ask, please reach out. I'm one of the most active ones, and I love Robert videos. I keep taking his videos and making, and sharing them and making comments. So please stay connected, and thank you for watching us today. And hopefully we can see you again with Robert maybe in the future.
Thank you very much, Wasim.
Thank you very much, Robert.
That's all for this video. I hope it was helpful. If you would like to learn more about electronics and board design, check out our online courses. You will find everything important there, from basic board design up to advanced board design and high-speed PCB layout. We have courses in Altium, Cadence, KeyCAD, and also courses covering many different topics, for example, FPGA, EMC measurements, and so on. Visit our website at fedevel.com. That's all for this video. Thank you very much for watching and don't forget to leave your comments. See you in the next video. Bye.